We seem to have had a tendency in the system dynamics field for the last 50 years to tell people system dynamics is massively powerful, but it's very, 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 very difficult. You can't possibly do it, right? This is easy. This really, really is easy. And remember that the people we're talking to are people like management accountants and business analysts and marketing analysts, people like that. They eat spreadsheets for breakfast, right? They can do anything you want them to do with spreadsheets, except they can't really do this. But there is a very simple parallel between these models and a spreadsheet. That item at the top there is our sales per week. So how many units are prescribed each week? You see a little time chart there on that. Think of that as a column in the spreadsheet with numbers going down for the 15 weeks. Right? That's what each object in this model is. It doesn't matter whether you're using this software or any other software in our field. That's always what they do. It's a column of numbers with a name at the top. Every link between those items is a set of cell references from one column to another. That's all it is. So that item is the lost profit, which is the profit we would have expected to make in one column of my spreadsheet, minus the profit we actually will make, given the model, in another column. You're just taking two columns away from each other. And inside every object is a formula, exactly like the formula you would have in a spreadsheet, except that our formula says revenue equals sales multiplied by price. It does not say A38 equals C$24 times $B, $18, right? It actually says sales multiplied by price. And because you can only use linked items here, it's almost impossible to make cell reference errors. Almost impossible. Right? Some research by a professor at Hawaii University has found that something like 80% of corporate spreadsheets have fundamental errors in them that make them give you the wrong answer for the purpose they were built for, and most of those errors are cell reference errors. We're using the wrong thing to do the calculations. You can't do it with this software or with any other software in our field. The other thing we're trying to do is we're trying to explain the real world. Now here, the real world we're trying to explain is what we fear will happen to the number of physicians. That's the red line. The simulation shows you in the blue line what the calculations say. If the blue line doesn't match the red line, the model's wrong. Right? Every single step you do, if the lines don't match, the model's wrong, so fix it. This could be copied in a spreadsheet. I could just take a table of all those variables out, stick them straight in the spreadsheet, replicate the equations, and there you would have the same model in a spreadsheet. But why would you bother? What's the point? It offers nothing more than you're getting in this, and actually rather less.